Hi, and welcome to this clip, having a little look at a leveled response question on halogens reactivity and the trends and what causes it, as well as some actual reactions between halides and halogens. So it's a leveled response. You can see this because of the little star up here. So as normal with leveled response questions, they quite often ask you to describe and explain. So in this case, they're looking for the relative reactivity of the halogens chlorine, bromine, and iodine. So they're not looking for the whole halogen group, literally just those three, so there's no point in talking about fluorine. And in the context of their redox reactions with halides, using reactions on a test tube scale. So they want reaction equations and observations in the answer. So the first thing to do is to plan out how to approach this kind of question. So describing and explaining the reactivity, you need to talk about things like shielding, electron shielding, atomic radius, etc., nuclear attraction, things like that linked to reactivity. In terms of the redox reactions to halides, that's the same as the displacement of less reactive halogens by more reactive ones. So the equation might look something like that. I'd suggest maybe using ionic equations because they're easier and more straightforward to deal with. So in this case, if you look at x2, you can see that that displaces y out of solution to form y2. So therefore, x is more reactive than y in this particular case. So thinking about how we structure it, we start off by just dealing with the reactivity and explanation first. Don't try and do all of it at once because it'll get a bit overwhelming. So you might want to do like a little table, or maybe just a section of the group from the periodic table like that, with your chlorine, your bromine, and your iodine, and an arrow pointing downwards. So the reactivity will decrease down the group. That's a simple recall. And that's due to increase in atomic radius, therefore more outer shell electron shielding. So there's less nuclear attraction for the outer shell electron. So therefore it's harder to gain another one in that outer shell. If you remember, what do halogens do in reactions? They gain an electron in their outer shell. So anything that slows that down is going to make that halogen less reactive. So the reaction equations and observations, it's basically thinking about what's going to displace what. So chlorine will displace the other two, bromine will displace iodine, but not chlorine. So you just construct an equation for each of those based on the idea down here in this model that we've just put down. So if you have chlorine and iodide ions, you can write it out with Cl2 plus 2I-. Now don't forget, I'm putting in the state symbols even though they didn't ask for them, because that just shows the examiner that I know it's all taking place in aqueous solution. So in terms of observation, if you don't add an organic layer such as cyclohexane, the brown colour will appear in aqueous solution as iodine is produced. If a non-polar solvent is added, the organic layer that will sit on top turns purple. So there's a choice of things you can put in there for your observations. For chlorine and bromide ions, similar idea, except this time the orange colour of bromine appears in aqueous solution as Br2 is produced, displaced out of the bromide ion solution. And if a non-polar solvent is added here, the organic layer will also turn orange. So making a bit of space bottom. If you add bromine to iodide ions, Br2 plus 2I-, giving you 2Br- plus I2, the orange colour darkens to brown in aqueous solution as more iodine is produced. If the non-polar solvent, e.g. cyclohexane, is added, the organic layer will turn purple. So this time iodine is being displaced again. So similar observations in the organic layer and the first and third reaction there. So you can see I've written the same thing twice, because what's happening is iodine being produced in two separate reactions there. So finally, you need to link those observations to your reactivity trend that you stated at the beginning. So that means chlorine must be the most reactive as it displaces both of their halides. Bromine is more reactive than iodide as it displaces I2, but it's less reactive than chlorine. Okay, I think that's probably enough for this question. There's different ways in which it can be approached. That's one way of doing it. Hopefully it's given you a bit of a heads up as to how to maybe structure your answer and what to put where. Okay, as always, thanks for listening. Until next time, see you soon.